actuates the valve of the car, either directly it actuates on the valve, or through a lash cup, or through a follower. Right? What we refer to as a load, same as a crankshaft. Everything in line here is a bearing to support the camshaft. The offsets here are the loads. The loads are what we use to open and close the valves. The height of that load determines how far that valve moves open. Okay? The more height, the higher the more opening you get on the valve. And not always more camshaft or bigger or more height is always what you want. It's not a good thing. You can open it too far and it will touch the top of the piston. Remember that. So whenever you swap it out of cam, you got to swap out some other things. You just can't go in.
I was about to ask the same thing.
You can't just go in and arbitrarily say more cam, more valve opening, more air, more power. It doesn't like to work like that. Sometimes you also have to specify the camshaft for your application. What do you want the car to do? Okay. A lot of people look at that and say bigger is better. No, it's not. Where do you want the car to work at? You know, I don't know, where do you drag race, road race?
Yes, that's me, right.
Oh.
They take over, he should say the line.
So every application is a little bit different, so you've got to know what you want to do with the car. What RPM range you want the car to work in, and then you have to specify your camshaft for that particular thing. How heavy is the car? So a lot of things come into play there. The cams can be, most are steel now. They're all steel. They can be hollow. Again, everything we use out there now is a roller. So they're going to be a forged steel camshaft. Very expensive. The wear characteristics are a lot better. The longevity there. Yeah, again, the roller makes life that much better. Less friction. Remember, it's easier for this wheel to roll across this than it is for this to slide across. And sliding across it actually creates a wear pattern. Metal against metal, or that thin film of oil. The wheel makes it that much easier. Less friction. Okay. Most of these lifters use a needle bearing. The needle bearing makes it roll that much smoother, limits the friction again. There's still some iron cams out there, not important. See, there's two answers here. One is, let's put it this way. Everything in the engine is driven off the crankshaft. Everything. So everything derives from there. All the oil pumps are driven by the crankshaft, which can in turn drive the distributor. In some cases, or the oil pump. But everything is driven off the crankshaft. Remember? Okay. This is an overhead valve setup. Okay. Where you get camshaft, roller lifter, push rod. Again, the push rod pushes on the lock rod to then open the valve. Now, camshafts have an opening ramp, and it also has a closing ramp. The one thing there is that the closing ramp does not close the valve. The valve spring closes the valve. valve spring closes the valve and keeps the valve closed. The ramp on the camshaft just aids it so it doesn't just slam it shut. It gently brings it down, brings it to the seat. It's the whole idea of the closing ramp there. And most of the world has gone away from this setup, except for, I'll show you this. I'm trying to like it.
What's the difference from a hydraulic?
A hydraulic lifter, we actually have an oil reservoir in it, and we use the oil to cushion the opening and closing. The solid lifter, we do not have oil. What we use is it's called a lash. So you use a gap between the tip of the rocker arm and the valve. So the lash is actually what cushions it. A solid's going to be noisier. You actually hear the ticking noise because of that lash. We're a Honda guys. You don't know what I'm talking about. Honda still uses a solid lifted camshaft in a lot of their cars. The rest of the world concerned with noise, so to minimize the noise, we put a hydraulic lifter in. They're using a solid lifter, right? You have to periodically go in and readjust that lash between the rocker arm and the tip of the valve. But solid lifter will actually make a little bit more power, and it can rev a lot more higher.
Gives you a lot better sound.
Well, no, that's not because it's solid. You can get the same load with either one. That goes back to the design of the cam, of the loads and what we call the duration of the camshaft. How long duration is how long we hang the valves open, and duration and overlap are what we use to get the load and make it sound good. Is what we do. Okay. Now, your overhead cams, which is almost the norm right now, we can actuate directly onto the valve. We can use a lash cup, or we use a follower. And again, this is a roller type. Minimize the friction here. So this follower actually actuates our valves and our engines, but we do have a lifter, but it's only there for the cushion to minimize the noise. So even though we're calling it a follower, it still can be referred to as a rocker arm, because it is a pivot point. Okay? And that's the difference. Rocker arm is just a pivot point. All right. Terminologies, and they're here. These are the basic ones you're going to need to look at. Critical point here is the timing point. Timing point here, the center of that camshaft, because the distance between that point and the center of the crankshaft has to be precise, or the timing chain or the timing belt do not work. Okay? So that distance has to be precise to get the timing right, to get the right amount of tension on the belt or the chain to make it work. So basically, these two center lines between this hole here and this hole have to be precise, or else this chain will have too much slack in it. Well, bike chain is adjustable. This has no adjustment. I know what you're doing, but see, we can adjust most motorcycles, bicycles. Well, yeah, but we can't do that.
Yeah.
Right. So they have to fit precisely because you got to slot them on all at once. Marks have to line up to get the timing right. Timing is everything. There's a lot going on here. If the timing's off, and again, if this valve is open and it's open at the wrong time, if it opens too early, the air fuel's going in while we're actually exhausting. So it's coming in and going out, or the valve can touch the top of the piston. It opens too late, there's no air fuel there. We fire the spark plug, there's nothing there for it to burn. Okay? Again, total misfire. You create issues. So the distance has to be correct in there. Solid lifter cam. If you're adjusting the valves, it's important that we adjust it with the cam on the heel. Okay? It's on the heel. There's no lift. There's zero lift there. That's what we know, and we adjust it at that point. Okay? If we adjust it anywhere else, it's not going to be right. And if the lash is not right, what happens? Same thing. We got too much lash, the valve won't close. It's going to be open. Okay. The flank or the ramp, You have an opening ramp and you have a closing ramp. They can be designed a little bit differently. We can actually hang the valve open a little bit longer by the way the ramp is designed on the closing side, or we can actually open it quickly, open it, peak, and then get to the top here. So we can change the designs on how the ramp is and how we open and close that valve. The nose is maximum lift. Okay. When it's on the nose, we get maximum lift there. That is the lift point. One thing about the nose, picking a camshaft, we only see this point one time there. We actually see this point and this point twice. Okay, you see it on the open and you see it on the close. So actually, these 2 points are a little bit more important than the total lift itself. Okay. So those are the things you gotta look at when you're choosing or